In this video, we are going to learn how to interpret a function graphically. So here, given the graph of a function, the first question is determine f of 2. So we learned that f of x is the function notation. So whatever's in the parentheses, that should be x. So what it's saying here is that x is 2. Then what is the corresponding y value? Remember, y is the same as f of x. So let's look on the graph. X is 2. This is where x is 2. But now we have to find a point on the graph that has x is equal to 2. That's going to be this point right here. That's the point where the x coordinate is 2. Now looking at the corresponding y value, that would be 5. So the answer for this is when x is 2, y is 5. The second one, part B, determine f of negative 5. So again, x is negative 5. So over here, now we'll have to look for a point on the graph. This time it's going to go down this way. Here's the point on the graph where x is negative 5. However, because this is an open circle, that means that point doesn't exist. So the answer for B should be it's not defined. Part C, find all x for which f of x is 0. Now the role reversed. So this time, given y is 0, remember f of x is the same as y, they're asking you to find x. So y is equal to 0. Here is 0, but y is equal to 0. That would be any point on the x-axis, but we need the points that are actually on the graph. So that's going to be this point and this point. So coordinates for this point is negative 4, 0. As you can see, y is 0 there. And the coordinates for this point is 4, 0. So when y is 0, x equals two values, 4 and negative 4. Next question. Find all x for which f of x is 3. So this time y is 3. They're asking you to find x. So y is 3. That would be this point right here. Now, as you can see that this whole line of the graph actually has y is equal to 3. So because it is not one single point like what we've been seeing in parts A, B, and C here, it's the whole segment of a line. So we're going to use an interval to describe that. So we're looking at x going from, looks like with this red segment, x goes from negative 3 all the way to 1. So we'll write x equals negative 3 to 1 with brackets. Furthermore, we also have this point. It's a little bit tricky here. This point also has y is equal to 3. Now, it doesn't look like it lands exactly at 3. It looks like it's between 2 and 3, so I'm just going to make an educated guess here. I'm just going to say it's about maybe 2.7. It's about 2.7. Okay, part E, determine the x-intercepts. X-intercepts are the point where the graph intersects with the x-axis. So that's going to be this point and this point. Those are the points that the graph intersects with the x-axis. So those points are, let's provide order pairs. So it's going to be negative 4, 0 and 4, 0. Determine the y-intercept. Y-intercept is the point where the graph intersects with the y-axis. So that's going to be this point right here. And that's going to be 0, 3. Determine the domain of f. Domain looking from left to right. So it looks like it goes from negative 5 as the graph travels all the way to the right. So it looks like it goes on forever to the right. So that means it will go all the way to infinity for the domain. So domain goes from -5 to infinity. Infinity will always use parentheses. Now as for the -5, we already talked about this open circle. That means the endpoint is not included, so -5 is not included. We're going to use parentheses for that as well. Now, if the domain refers to left to right on the graph, then the range will refer to the lowest to the highest, the vertical direction this time. So looking at the graph, it looks like, how low does the graph go? This arrow points down forever to -infinity in the vertical direction. So the range should go from -infinity all the way up to the highest point. That's the highest that this graph can get, which is 5. So it's going to be -infinity to 5. It looks like 5 is included because there's no open circle up here. It's a solid line. So we are going to use bracket for the 5.